Good afternoon, ladies and gentlemen. We are going to be working on an example problem that may help you with steps 3 and 4 of your current activity 4.3, and it is upside down. There we go. All right, so I've set up a very similar problem to the one that you guys are working on with different numbers in a different situation. This is modeled after a just afternoon that I might have after leaving work. Hold on. All right, that's better. Okay, so it says Mr. Barnhart leaves Soulsville and bikes 15 minutes to Kroger. He shops for 30 minutes and then bikes to the hospital to take his wife dinner because my wife works in the hospital. And it takes him 10 minutes to get to the hospital. He spends 20 minutes at the hospital and then bikes home in 15 minutes. Now, your first step was to create the motion graph for each of those. So let's go ahead and make my motion graph. So I'm going to have on I've already made my x-axis for time, and I did mine so that each of these squares is worth 5 minutes. And then on the y-axis, I'm going to have, let's see, my total distance is 2.5 miles. No, 3.5 miles. So I'll have this be 1 mile, 2 miles, 3 miles, and then that top one's going to be 4 miles, but we're not actually going to get to there. All right, and this is a map, or this is a chart showing the displacement, not the total distance. Those are very different because displacement is just the distance from Soulsville. So my 0 is from Soulsville. And then I'm going to go ahead and just mark on my graph on the y-axis where each of these things is. So it told me that Soulsville is 1.5 miles from the hospital. So I know that the hospital is here at that 1.5 mile line. And then it said 1.1 miles away from that. So I'm going to go up one and a little bit, is Kroger. I'm going to call that K. And then it said 0.9 miles from that, so a little bit less than a mile is going to be my home, and I'm going to call that, I've already got an H, so I'll just write home. I'll call that Haas just to make sure we're clear. And so I know that my hospital is along this line, that Kroger is right above this line at 1.1 away from that, and then that home is along this line, which is a total of 3.5 miles away. Now I'm ready to get started. So I know, let's see, it says leave Soulsville, so my 0 is going to be here. And then it says in 15 minutes he got to Kroger. So I go over to my 15 minutes, and here I was at Kroger. And I'm going to go ahead and put all my dots on before I draw any lines. Then it says he shops for 30 minutes. So for 30 minutes, I was not moving. And so I stayed at Kroger for that whole 30 minutes. So total, so 30 minutes plus another 30 minutes. I'm sorry, 15 minutes plus 15 minutes is 30 minutes. So all the way to here, I stayed at Kroger, not moving. That's going to be a flat line. Anytime I'm not moving, I should have a flat line. Let's see. Then he bikes to the hospital to take his wife dinner. So I'm actually going back towards Soulsville now. I'm not going up farther away, I'm going back towards it. So my hospital is on the line over here. So I know it's going to be somewhere along here, and it says it takes him 10 minutes to get to the hospital. So go to the hospital here. Okay. And then He spends 20 minutes at the hospital, so 5, 10, 15, 20, I'm not moving. And then bikes home. Home is way up here in 15 minutes, so 5, 10, 15 minutes. And then my home line is here. And then I'm going to go ahead and draw in my lines. If you would like to have nice, perfect lines, you can use a ruler. You're welcome to ask me for one in class, but I'm just going to freehand them. And then it actually didn't say so in the problem, but I'm just going to assume that I stay at home after that so that it looks a lot like yours. So my numbers are different, so it's not going to look exactly like this, but your graph should look a lot like this. So now I'm going to move on to 4. So it asked me after 1.5 hours, but that's like the whole time for me. So I'm going to choose a different amount of time. I'm going to say, for my example, it'll be after, we'll say 1 hour, so 60 minutes. So at 60 minutes, I'm going to plot that and call that A. All right, and then B. So what is the total distance they walked after an hour and a half? Okay, so again, I'm using, I'm just gonna cross this out, 1 hour, and then cross that, so 1 hour, because my example is a little bit different. Don't do that on yours, this is just for my example. So the total distance at 60 minutes. So I'm here at the hospital at 60 minutes, but I didn't go straight to the hospital. If I'd gone straight to the hospital, I just would have gone 1.5 miles, but I went to Kroger first. I went all the way to Kroger, so that was 1B. So I went TSCS to Kroger, and that was 1.5 plus 1.1 miles, which is a total of 2.6. And then I went from Kroger down back to the hospital, which was 1.1 miles. And so my total distance is from Soulsville to Kroger back to the hospital. So that equals 1.1 plus 2.6 and equals 3.7 miles. All right, so let me for B. And for C, it said what was his displacement at an hour and 50 minutes. I'm not really sure where that would be on here, so I'm just going to choose an arbitrary point. I'll say, we'll call this point C. All right, so this time it said displacement. Oh, and what time was that on? 75, 75, 80, 85. We'll call that 86 minutes for me. I don't really know why I did 86 minutes. That's not a very good one. 86 minutes. All right, this time though, as I circled here, it says displacement. This is different from distance because this is only from Soulsville to C. It is just the displacement is not the total distance I traveled. It is the distance directly from Soulsville to that point. And so in this case, that would be 3 miles. And C, displacement equals 3 miles. All right, we're going to pause right there, and I'll pick this up on the next video.